Welcome back to Math Mini Lessons, Math Marvels. This is our breakdown of the 2025 New York State exam. We're going to have two videos, one for part 1 and the second one for part 2. If you would like a link to these release questions, just check in the comments. I'll send you a link so that you can get the entire PDF and try out for yourself. Now, if you've done these before, usually I go over every single answer. So take a copy of this test yourself, try it out, and if there's a question that you're not sure about, watch here in the video. I've broken down all the chapters on the bottom. So here we go. Okay, tips for taking the test. Of course, they tell you to try to do your best, read every question carefully, take your time, use the ruler and protractor. But guess what? This test is on a computer, especially if you're taking it in English. If you are taking it in another language, you'll get it on paper. But if you're taking it in English, you will be on computer, which means a few things. So I'm going to give you some additional tips. Two, really. So one, I want you to really use your scrap paper. And I have an example of it here. And what I would tell you is to do two things with it. Fold it into 4 different sections and then keep your work organized. So what I would do if I were you, again, I would just fold it in half and then in half again. And I would number all parts of the paper. And then when you turn it around, I would number it again. So you have another 4 boxes. So that one piece of scrap paper, you can 8 questions. And if you get 3 more, that will cover you for this entire test. And that's super helpful because on the state test, they give you this little note-taking thing where if you want to go back, you can go back and find your notes. You're probably never going to use that. If you need to go back to a problem, you can literally look at your paper and I'll give you some symbols that you can use to see how sure you are. Like if you know that you're really confident, give yourself a check. If you're not so sure, give yourself a question mark, or if you need to come back, maybe star it so you can go and look at your paper to figure out if you need to come back or not. Because in the thick of it, when you're done with the test or when you're coming to the end, you're just going to want to get it over with because you're going to feel tired. But if you look at your notes, you can know where you need to go back and where you don't. The other thing that you can do is just make sure that you're showing all your thinking. Really work out the problem so that you can see what's really happening there. So you can see if you're eliminating. So if I'm squaring up my paper, maybe I have A, B, C, D, and maybe I'm eliminating 2, but I want to show all my thinking on the page. Don't try to do it in your head. If you try to keep track of a bunch of numbers in your head, it's like having too many apps open on your phone. You will get tired because your brain is holding on to too much stuff. And then when you really need your brain to work on those problems at the end, because the test gets more challenging as you go, you're not going to have the energy. Your brain's going to be super tired and that's going to be frustrating for you. So don't keep all those numbers in your head. Use your paper. Okay, the other tip I'm going to have for you is on this release section of the test, the state doesn't show every question when they show these tests to the public. So they've taken out some at the very end of this video. I will tell you about 7 to 9 of the questions. I figured out what kinds of questions they were, so you can also practice those questions even though they're not on this test. Okay, so we're going to jump into part 1, which is all multiple choice. Number 1 is skipped, so it's going to start with number 2, and I'm going to give you the reveal first so you can see if you got the right answer. If you got it and you feel confident, go to the next chapter. If not, stay here and I'll show you how I break it down. All right, the answer for this one for number 1 is D. Okay, if you got it right, keep moving. If not, stay right here if you want to see how I break it down. So this is one of those problems where you definitely should just work out the math itself. Which expression has the same value? So all they're looking for is an equal expression that will make 28 over 6. So that's what they're looking for. Which one has the same value? So on your scrap paper, I would just put each of the parts in there. So I would have 14 times 1/2. And I'm going to put 14 over 1. So this is A. And I'm just going to multiply it out. 14 over 2. That doesn't match. I can eliminate. Let's do B. 14 over 1 times 1/6. 14 over 6. That's not the same as 28 over 6. I cross it out. C. 28 over 1 times 1/2. I get 28 over 2. Same numerator, but not the denominator, so I can eliminate. And here's our answer for D. 28 over 1 times 1/6 is 28 over 6, which is the correct answer. So things you had to know for this one, you had to know that when you multiply a whole number times a fraction, you can turn that whole number into a fraction by simply putting it over 1. It will not change the value. And the second thing you need to know is when you multiply fractions, we multiply numerators and denominators together. So numerator times numerator, denominator times denominator. And all they were looking for is they're not looking for you to actually, they just wanted to see which one has the exact same value. So you actually had to do all of them to find which one it was. All right, hit pause and jot this one down into your notes. Okay, let's look at question 5. I'm going to give you the reveal in 3, 2, 1. The answer is D. Check with your work, see if you had the same answer. If you did, skip to the next chapter. If not, you can stay right here. So this is just multiplying 542 times 9. So I'm going to show you 2 different ways you can do this. The first one using an area model, and the second one is just using traditional multiplication, which is probably the way a lot of our parents learn how to do this. So for the area model, I'm just going to take a rectangle and I'm going to decompose 542 into 540 and 2, and I'm going to multiply by 9. And I'm just going to multiply each of these in each box. So 9 times 2 is 18. 9 times 40, in my head I'm just doing 9 times 4, which is 36 times 10. And 9 times 5 is 45 times 100 is 4,500. And now I just have to add these 3 numbers together. What I like about this one is that all I'm doing is multiplying by 1 digit. So I'm not multiplying here, I'm just adding. And I'm just thinking about each number separately. I don't have to worry about any regrouping. And that kind of helps a lot of kids avoid some really missable mistakes. But you see here, when I add it all up, I get 4,878. Pretty easy. Now, if you want to do traditional, which is also fine. Some people find traditional way faster. That's okay. You're still doing the same multiplication. You're still doing 9 times 2, which is 18. Only you're regrouping the 1 in the tens place. 9 times 4 is 36 plus that 1. So you're getting that 37. And regrouping the 3 to the hundreds place. 9 times 5 is 45. Plus 3 is 48. So there you go. Both exact same answer. Doesn't matter me one way or another which one you use. Think about the one that makes the most sense to you. Which one is the most helpful for you, where you feel you're less likely to make a mistake. All right, hit pause and jot this down into your notes. Okay, so it skips over from question 5 all the way to 13. It skipped 6 through 12. Here's the reveal for 13 and 14. D and B. Check with your notes. See if you had the same answers. If you did, great, and you understand it. Keep moving to the next chapter. If not, stay here. So starting with the first one, it's asking me that question again about having the same value. We want which expression has the same value as 13 over 10. So on my scrap paper, I'm going to go into that square for number 13, and I'm going to put in my 2 numbers. Now, because these fractions have the same denominator, I can add them without making any changes. So 8 plus 5 is 13, 13 fifths. Now, at first, I'm going to confess, when I was first doing these problems super fast, I just saw 13 and saw 13 up here too. And I was like, hey, maybe A is the answer, without thinking, Sarah, look at those denominators. They're different. One's a 5 and one's a 10. So this is where rushing can really go against us, because you're looking for the 13, but we're looking for the entire fraction has to be the same. So A, these are not equivalent. 13 fifths is not the same as 13 tenths. So we'll go into B, and you'll do the same thing. You'll just add all of them together. Now, the silly part is in this one, they're all now different denominators. I have 5s and 10s, so I have to make them all the same. And the way I can get 8 over 5, well, I know 5 times 2 is 10, so 8 times 2 is 16. And I'm going to do the same thing with the second one. 5 times 2 is 10, so 2 times 2 is 4. And it's probably going to come up in another problem to make an equivalent expression. equivalent fraction. Now I can add them. 16 plus 4 is 20, plus 3 is 23, and that's too many for me. We're going to delete it. Let's go to C, and we have 8/10 plus 5/5. And in this one, again, even though they're different, and I see that they're definitely different, at least this one here I know is just the same way as saying 1. So I'm going to rewrite this as 8/10 plus 10/10, just to make it easy and the same, and I get 18/10. So nope, that's not the same value. And obviously we know this one's going to be the right one. Luckily they're all the same denominator, so I don't have much to do here. 8 plus 2 is 10, plus 3 is 13. And that matches what I was looking for. So D is the correct answer. Let's move down to 14, which is a rounding one. The price of a house rounded to the nearest $10,000 is $220,000, which could be the price of the house. So this is another one where, again, super helpful on your paper to just work them all out. And we're going to use our rounding rules. I'm going to find the number that's in the 10,000s place. Here it is. It's a 1. And I'm going to always look at the buddy right behind it. And I'm going to ask myself a question. And do I round up or do I round down? Remember, if it's 0 to 4, then you're going to round down. And it'll just be 21 and just make a 0. If it's 5 or more, you round up. That number, that underlying number will go up 1 digit. It will go up another 1. Okay, so looking here, my buddy is a 3, so I'm going to round down. That makes this 210,000. Okay, so that's not the number we're looking for. We're looking for this one over here. So I'm going to do the next one. Again, here's my number in the 10,000s. Look at your buddy. It's a 4, so I'm going to round down. So it's my underlying number, my 2, stays a 2, and everything goes to 0. That is the correct one. So that is the nearest 10,000. Now, if you wanted to check the other ones, you can. But we know they're not going to work because there can't be 2 right answers here. So here's my 10,000s place. My digit is an 8, so I'm going to round up. So this goes, my 2 becomes a 3. And everything else is a 0, so that doesn't work. And my last one, 230,150. Here's my 10,000s place. My buddy right after is a 0, so it's going to round down to 230,000. All right, hit pause and jot these both down into your notes. If you had a different answer, you can now change it, and hopefully you can see why. And just like in my other breakdown videos for the state test, please add to the comments if you had additional questions or if there's something else you need to see. All right, here's 17, 18, and 19. Let's do the reveal. We have D, C, and C. Check with your answers. If you feel pretty confident, keep moving. If not, stay here. We'll start with number 17. Sam buys, since this was a longer, I'm going to read it actually more than once. Sam buys 4 packages of baseball cards. Each package has 12 cards. Sam gives all the baseball cards to 3 friends. Each friend receives the same amount of cards, same number of cards. Which set of equations can be used to determine the number of cards C each friend receives? Okay, so now I can read for that information. What are they asking me to find? They want me to find which set of equations can be used to determine the number of cards that each friend gets. Okay, what's the important information? So this is where I'm thinking about what's the other good information I need. Well, I know that he buys 4 packs of cards and that each pack has 12 cards and that he gives all the cards. He has 3 friends. So that's going to help me. So now let's think of strategy. Well, I'm going to tell the story. 3 things happened in the story. So in the first one, he has 4 packs of cards and there's 12 cards in every pack. So I know that's 4 times 12. I know he has 36. Oops, not 36 there. What's going on? That will give him his 48 cards. Well, more proof that I'm not AI, because you just saw me make a mistake in real time and fix it. So what's the next thing that happens? he's going to share them with 3 friends. Oh, okay. So he's just going to divide it by 3 friends. And that's going to tell me how many cards he gets. Now, here's the thing. They're not asking me to solve it. They're just telling me to figure out the equation. So if I wanted to, I can keep on solving this, but I don't need to for this problem. So that's going to tell me how many cards he has. Oh, and there actually is another step. So I just use the information to do 2 expressions. So what matches that? So I'm looking for this thing to happen first, the 4 times 12. So definitely not A. Definitely not C, where they're adding 4 and 12. No, I'm multiplying them because I want to figure out how many cards there are. So let me see. So this is true. 12 times 4 is 48. That is true. Okay. So then my next step was to share them with his 3 friends. I used division, and that's going to give me the number of cards C. So in this one, he multiplied by 3. Nope. He did not give each friend 48 cards. He only has 48 cards, and he divides it by 3. So there you go. So there you go. I've kind of seen this in every different grade where they tell a story and they're trying to get you to figure out like the different parts of the story as expressions or how to work them out. Let's look at the next one. This one's, I don't have to read it 3 times. Which expression is equivalent? So another one where they're testing us to see which one is the same as the expression 8 times 3 times 5. So in this case, what I will probably do is I can actually multiply this one because none of these looks like 8 times 3 times divided by 5. They don't look the same. So I'm actually going to multiply this out, and I would get 8 over 1 times 3 over 5 gives me 24 over 5. So I want, ultimately, it should simplify. Whatever expression I have should also simplify to 24 over 5. Like that should be what it was worked out. So I'm going to do the same thing on my scrap paper. I'm going to do 11 over 1 times 1/5, and that gives me 11 over 5. That's not the same. 11 over 1 times 3/5 gives me 33 over 5. Nope, not what I'm looking for. My brain is focused, man. It knows it wants a 24. 24 over 1 times 1/5. This one looks so promising. 24 over 5. And there's my answer. And just to make sure, 24 times 3 is 72 over 5, which I know is incorrect. So C is the correct answer. Now, I have also seen in a lot of these types of problems, I have seen some people just rewrite this as taking these 2 numbers up here and going, well, this is the same as 24 times the unit fraction 1 over 5. So I've seen that, where some people rewrite it in that way. And that's okay too. It doesn't always work. It actually kind of does right here. But I find instead of trying to figure out what it could be, I find just simplify, just actually do the work, and you can see whether or not 2 expressions are going to be equivalent to each other. So when the expressions look different, I can simplify them out, work through them to see if they simplify to the same thing. Okay. Now let's look at number 19 here. In which number does the 7, and this one is tricky, so I want to go through the language carefully. In which number does the digit 7 represent a value that is 10 times greater than the 7 in 27,325? Okay, so I want to know a 7 that is 10 times bigger than this 7 over here. So this 7 is worth 7,000. Doesn't look like a cute 7. Let's make it a little cuter. There we go. 7,000. And I want to know which 7 is 10 times bigger. So if I multiply this by 10, I know I'm supposed to get 70,000. So I am looking for the number that has a 7 in the 10,000th place. So when I look at this one, nope, this is only 700. This one is only 7,000. Which I can see a lot of kids choosing because it has the same value. But this is the one that has it because my 7 is in the 10,000th place. And this one has it only in the 70s. Okay. All right, hit pause and jot this down into your notes. We've skipped 20 and 21, so let's show the answer for 22. The answer is A. All right, let's read the problem. Rob draws a rectangle with a length of 6 inches and an area of 24 inches. What is the width in inches of his rectangle? Okay, so what's the important information? We know it's a rectangle, length of 6, area of 24. So I'm going to take advantage of the space up here. Here's my rectangle. One side is 6. I have no idea what this side is, but I know my area is 24. That means the number of square units inside. So I want to know what this number is. All right, so what do we know about area? We know that area is equal to length times the width. So in this case, I have the area, which is 24, is equal to 6 times some number that I don't know. So this is where you can start thinking of your math facts. So if you did your triangle, like think of the relationship, I know 24 will be on the top. 6 times what gives me 24? The answer is 4. And that's it. So all I'm doing here. Now where kids get pretty tripped up is that sometimes kids put the 24 as the length and then they end up multiplying 6 times 24. So I've seen that kind of happen. So just be aware of that. I've also seen some kids just do 6 taken from 24, and that's how they might get 18, which notice they put that in there. Or some kids might just add those two numbers together to get 30. Notice they put that in there. So they do put answers because they know that kids might make an error somewhere, and they also have some crazy number that makes no sense. All right, hit pause and jot this down into your notes. They skipped 23, so we're going to go right to 24 and 25. Our answers are D and A. Check if you work. If you got them and you feel confident, skip to the next chapter. All right, we're going to start with 24, which is a comparison, and we're comparing two fractions. I'm going to use my property of 1 to compare my fractions, meaning it's really hard to compare apples and oranges when things look different. So much more, it's so much easier when they have the same denominator, when they look the same. So what I'm going to do is I'm going to use my property of 1, which is I'm going to multiply by 1 in different fraction forms to make the denominators the same. That way it's easier for me to compare. So in this case, this one's pretty easy. I can just think, what could I multiply by? I know that 2 times 3 makes 6. And I know that 2 times 1, yeah, that doesn't make 4. So this is not a true statement. They're not equal to each other. So I can cross that one out. We're going to go to B. 2/5 is less than 4/10. So again, I want them to look the same. So we're going to use property of 1. So I know that 5 times 2 makes 10. So 2 times 2 makes 4. So this is what I'm saying. 2 times 2 is 4. 2 times 5 is 10. Is 10 less than 4/10? That's not a true statement. Those are both equal to each other, so I can cross that out. So I wanted you to see that before. I don't think I made that clear in the first one, that I had 2/6 and 4/6. So I knew that that could not be a true statement. All right, let's go to C. And I have 3/4 is greater than 7/8. Okay, what would I multiply? I'm multiplying, I know that 4 times 2 makes 8. So I'm going to multiply by 2 on the top. This is what I mean by property of 1, because this is still multiplying by 1. So my fraction has the same value. Okay, 2 times 3 is 6. 2 times 4 is 8. Is 6/8 greater than 7/8? No, it is not. So I can eliminate that one. And we're going to go to D, which is our last hope. But we don't want to just pick it. We want to just really make sure. Okay. So in this case, I know they're different denominators. And you might have to do a lot of stuff with multiplying to get there. But I want you to just think, what else do you recognize about these fractions? I recognize that 5 out of 10 is half. And 3 out of 6 is half. And so they are equal to each other. So D is the correct answer. I did want to show you another strategy for 24, but I think I'm going to save it for another video because I don't want to confuse you if you have a way that works. Let's look at 25. A group of friends is sharing 6 cookies. The number of cookies is 2 times the number of friends. What equation can be used to determine the number of friends? Okay, so we have a group of friends they share the 6 cookies. The number of cookies is 2 times the number of friends. Okay, so I have 6 cookies and the number of cookies is, so 6 is 2 times the number of friends. What I'm doing is I'm translating the problem, and that's where I can get 6 is equal to 2 times the numbers of friends. So how can I figure out the number of friends? So the first thing my brain did was I went, this looks like it, but no, because I want the F by itself. So we're going to rewrite the sentence. 2 times some number makes 6. So think about your fact families. 2 times some number makes 6. I could also rewrite that as 6 divided by 2 gives me that number. And there is A. So you see how, again, your brain can play tricks on you because it sees to the things it wants to see, and it kind of wants to rush to that. And that's why we want to take our time and make sure that we're really looking for the right thing. So there you have it. I figured out how to once I knew what the relationship was and translated it, I can make a brand new expression. This is not the easiest problem, but it's one of the reasons why we don't rush. And notice how late this problem comes out. This is the type of problem, is number 25 is close to the end, where kids are much more likely to rush and make a mistake because they want to get to number 30. All right, hit pause and jot this down into your notes. We've skipped 26, so we're going to go down to 27. Which value can replace the unknown to make the equation true? So pretty much all they're asking us here is what's the missing number. The correct answer is A, 3/4. If you have it, move to the next chapter. If not, stay right here. So the first thing I would do in a problem like this is, if I know 3 2/4 plus some number equals 4 1/4, so I'm going to rewrite this using subtraction. 4 1/4 minus 3 2/4 is going to give me that number. So that's the first thing. Luckily, we see that both denominators are exactly the same, but I don't have enough to subtract, so I have to do some regrouping here. So I'm going to take one of these and I'm going to leave this as a 3, and instead I have 4/4 plus the 1/4. So you can kind of see where I'm getting it from, and now I'm going to have 3 5/4 minus 3 2/4. Now I can subtract. 3 minus 3 is 0. This, I know my fractions fourths. And 5 minus 2 is 3, or 3/4. So there you have it. All right, hit pause and jot this down into your notes. Typically, I kind of stack these on top of each other to make it easier, but I don't know, I just wrote it horizontally this time. But you did have to do some regrouping in order to subtract. Almost at the end, and most kids are probably at the 1 hour mark about taking this test. If the entire test was there, if they hadn't skipped any problems, I think 4th graders usually take anywhere between 1 to 2 hours to finish the exam on the multiple choice day. Nevertheless, here are the answers for 28 and 29. B and D. Check your answers, and if you had something different, stay here. If not, move to the very last question. All right, starting with 28, it's a simple computation problem. We want to know the quotient. They're just asking us to divide. So I am going to use both methods for division for this one, just because division is that type of subject where it feels like a lot of work and it feels overwhelming when we look at it. And I think if you start having success with it when you're learning it, it will feel faster later. So I'm going to give you a different model for this, and this is using, it feels like an area model the way I'm going to break it down. So I'm going to have my numbers in here: 4, 5, 2, and 3. And in every single box, I'm just going to try and figure out how many 4s I can take out. So in the first one, 4 divided by 4 is just 1. So I know that's just one group of 4. And and I get 0. That works. And how many 4s can I take out of 5? 1. And I also like this because I've literally seen some kids go and say, all right, 1, 2, 3, 4, 5, I can take 1. I've seen kids do things like this for whatever makes sense. I actually just use the numbers. That's just me. So I can take one group of 4 out, and I have 1 left. Now this is where this model is super helpful, because now I'm going to take this 1 and put it over here to make 12. This is what makes this model super cool. So now I'm thinking, how many 4s can I take from 12? I can take 3 groups of 4s. How much is 3 groups of 4? 12. And I have 0. So when I have nothing to take to the other side. And how many 4s can I take out of 3? None. So my remainder is just 3, because I can't take anything out of there. And that's it. My answer is 1130. Notice I had to put that 0 up there. 1130 with a remainder of 3. So moms and dads, please don't get upset and think we've changed math. It's not that. We just recognize that sometimes seeing it a little bit differently, it's the same steps, can help when kids are learning early. Because eventually we do want to get them to traditional long division, which feels very familiar. And it's the same process where now we're going to do the same steps. Divide, multiply, subtract, bring it down. Hey, we're going to do those steps. But we're going to do one number at a time. So starting with the 4, divide. 4 divided by 4 is 1. Multiply. 1 times 4 is 4. Subtract. 0. Bring down the next number, 5. Divide. 5 divided by 4 is 1. Multiply. 1 times 4 is 4. Subtract. I get 1. Bring down the next number, 2. Divide. 12 divided by 4 is 3. Multiply. 4 times 3 is 12. Subtract. 0. Bring down to 3. Divide. 4 can't go into 3, so I have to put a 0. So that's the other point I want to give to you guys. If I have 3, like 1, 2, 3, 4 numbers here, I should have 4 digits up here, even if it's a 0. Even if it's a 0, every single number should have a digit on top. And so my remainder is 3. So both methods work. Again, doesn't matter. Use the one that you feel most confident with. I will say that some kids start here, and the goal is to get them to this one over here. All right, let's look at number 29. Which number is a multiple of 8 and has a factor of 3? So we're looking for 2 things. We're looking for a multiple of 8, meaning I can skip count by 8, but it's a factor of 3. I can divide by 3. So to do this one, I'm actually going to work off of those numbers first. And now I'm going to start with 8s, and I'm going to just skip count by 8s. 8, 16, 24, 32, 40, and 48. And just looking at these numbers here, I noticed that 16 is a multiple of 8, but not 18. So I can eliminate 18. But I see the other 2. So I see 16, I see 32, and I see 48. Cool beans. Now the next part is which one has a factor of 3. Meaning, can I divide any of these numbers by 3? 8 divided by 3? No, that's not going to be an even number. I'm going to end up getting 2 and 2/3, so that's not a factor. Let's see 24. 24 divided by 3? Yes, 24. And notice I am writing as a fraction, division as a fraction. 24 divided by 3 is 8. But not on my list. So that sucks. So I'm going to go to the next one, 32. 32 divided by 3. Well, that's 10 and remainder of 2/3. So I'm not going to go to 40 because it's not on my list. I'm going to go to 48. 48 divided by 3. Well, I will say there is a way to look at a number and know if it's a multiple of 3. I'll tell you after this one. You're going to be like, why didn't you start with that, Sarah? All right. 48 divided by 3. I'm going to use my long division here. 4 divided by 3 is 1. 1 times 3 is 3. Bring down the 8. 18 divided by 3 is 6. 6 times 3 is 18. So yep, 3 times 16 makes 48. 48 is a factor of 3. I will tell you this about multiples of 3. If there used to be a song 369, monkey drank wine, I used to say it to myself all the time. So if the digits of a number add up to 3, 6, or 9, that number has 3 as a factor. How do I know this? Give count by 3s. 3, 6, 9, right? 12, 1 plus 2 is 3. 15, 1 plus 5 is 6. 18, 1 plus 8 is 9. 21, 2 plus 1 is 3. 24, 2 plus 4 is 6. 27, 2 and 7 is 9. 30, 3 and 0. 33, 3 plus 3 is 6. 36, 3 and 6 is 9. And it keeps on going like that. So that's another way of finding factors for 3. You can check out our videos for other patterns with factors, and we can talk about why they're true in other videos. All right, hit pause and jot this down into your notes. And we made it to number 30. But if you want to know what kinds of questions were skipped, I did figure out where some of them were. So just you can skip to the end after this one if you're ready. All right, number 30, the answer is C. So let's jump into it. The model shown below represents one whole and is divided into 12 equal parts. How many of the 12 equal parts in the model should be shaded to represent a fraction equivalent to 3/4 of the whole? So awesome. We want to know how many of these pieces we're going to shade if 3/4 is shaded. So one way I kind of think about this is every time if I count for every 4 I count, for every 4, I'm going to shade 3. So I'm going to shade 3 when I count 4. Okay? So 1, 2, 3, 4, I'm literally going to shade 3 of them in. Go to the next one. 1, 2, 3, 4. I'm going to shade 3 of them in. 1, 2, 3, 4. I'm going to shade 3 of them in. That's the math work I'm doing. I'm just literally splitting it up into groups of 4s. Now, I like this method because even if it's not an equal thing, like let's say you wanted, if it was 3/5, I would still count 1, 2, 3, 4, 5 and shade 3. So this is a way of telling me how many groups and how I would shade it. Again, that's all I would do. So here's 1, 2, 3. 1, 2, 3 out of 4. 1, 2, 3 out of 4. And that's how I got 9. Another way of doing this would have been to say, I want to shade 3/4, and I know I have 12. So 3 out of 4, if 4 is the whole group. So how many is that out of 12? This is where you can use your multiplying by 1, your identity property again. Well, I know that 3 times 4 makes 12. So 3 times 3 makes 9. Again, all I'm doing is multiplying by 1 in a fractional form, which I can be really flexible with, to create an equivalent fraction. And that will tell me that I can shade 9 out of 12. All right, that's the last multiple choice one. Hit pause and jot this down to your notes, and I'll tell you what kind of questions were not included in the first part of this test. Okay, so in part 1, there are 30 multiple choice questions, and I will tell you that in this released copy of the test, they cut out 14 questions. They don't show you the entire test because they don't want to give every single question in middle school and elementary school. However, you can find it when you go to high school. The entire Regents is always online. But people always ask me, Sarah, well, what kinds of questions are there so my kid can practice? Because guess what? Kids in every school I know of in New York use these tests to actually practice for the state test as well. So when you don't know what kinds of questions are missing, you may not know what kind of things to study for. So I was able to figure out at least 9 of them out of the 14. So that's something. So here are the ones that I was able to find. All right, number 1, I was able to find, the first one was comparing multi-digit numbers. So they might have something like 4,327 compared to some other number, some other 4-digit number, and you had to say which one was either larger or smaller. So that was the first kind of question that I was able to find. Then I found a multiplication problem was missing where they either have a 2 by 2 like 45 plus times 55 or a 3 times 1 number for multiplication. So some type of multi-digit multiplication. Then I was able to find they have some type of division problem where you're going to do something like, some type of number divided by 4 or 5, something like that. But it's usually divided by a 1-digit number. Some type of multiplication sentence. So they might say, this number is 3 times the number 28 in words, and you have to turn it into an equation. So if they say the number 28 is, I'm going to say 28 equals, and then I'd figure out what the rest means. Usually they use words like double or triple, whatever, or 3 times. Then they're going to have some type of estimation problem where you're going to have to round to figure it out. Some type of line plot, usually it's a measurement problem where they have like time or feet or inches, something where the numbers are also have mixed numbers and fractions. So there's always something like that. And they might ask you which is the biggest number minus the smallest number, something. They might have something where you're adding or subtracting from 1, or something like you have 5/8. How many more do you need to get to 1? And you're going to subtract and figure out what the rest of the fraction would be. They'll ask you some type of question about lines and angles. So like, do you recognize, which are the parallel lines, or these 2 lines, are they parallel? Are they perpendicular? So parallel, we know they'll never meet. Perpendicular, they'll make right angles. If intersecting, it just means they cross somewhere. Or they might ask you about the angles. Are they acute, obtuse? Is it a right angle, straight angle? They might ask you something like that. And lastly, they'll give you some type of parallelogram and they'll ask you what kind it is. So parallelograms have 2 sets of parallel lines. If it only has 1 set, it's a trapezoid. So that's 1 set, or this is 1 set. Those are trapezoids. So parallelograms have 2 sets. So it might be a rectangle. It might be a square. It might be a rhombus, like a perfect one that all sides are the same. It might be one that looks a little bit more stretched out, like this. So they'll ask you something like that. But that's all I can find. I still don't know what the last 5 questions were. But at least I will tell you that between these 9 and everything you see on this test, every single type of question is asked on 4th grade. So like my other videos, please let me know if you have questions. Put them into the comments. If this video was helpful, let me know. I make them every single year to help kids on the state test. And as always, if there's something you'd like to know more about, just ask me in the comments. This goes for moms, for teachers, for dads, for kids. Just ask and I can make those videos for you as well. That's it for today. You can check for part 2 of this video with the rest of the multiple choice and constructive response. And I will see you next time, Math Marvels. Bye!